So example 25, log base 5 of 4 plus log base 5 of x equals log base 5 of 36. So this is great because we have log base 5 everywhere, but there are two of them on the left side and only one on the right. So currently it's not balanced, okay? So when we have multiple logs, guys, we have to condense it down to just one log. So on the left side is log base 5 of 4 plus log base 5 of x. So we need to use the product property. So when it is an addition in log, the product property says we can write it as a multiplication. So it's going to say 4 times x, okay? So log base 5 of 4 times x equals log base 5 of 36. Now we have one log on each side. Why don't you guys take a second or two to finish solving for this? Don't forget to plug it back in and check to see log is not negative, okay? So as you can see, we have x equal to 9, and we can quickly plug it back in. Log base 5, there's only one location that has an x, and when we plug 9 back in, that's not negative. So now we can see that this one has 2 logs on the left side and no log on the right. And as you guys remember, if we have multiple logs, we have to condense it, right? Okay, so let's condense. This is an addition, so we would need to use the product rule. So log base 4 of x plus 2 times x minus 4. Hold on, I'm a little frozen. There you go. X minus 4 equals 2. So we are going to distribute this out. Okay, so log base 4 of x squared. X times negative 4 is negative 4x. 2 times x is positive 2x. 2 times negative 4 is negative 8 equals 2. Combine like terms in the middle. So log base 4 of x squared minus 2x, y'all, minus 8 equals 2. Now, what case is this one? Case 1 or case 2? Case number 2, right? Because we have one log on the left, but no log on the right. So case 2 said we have to rewrite it as an exponential if we only have one log. So we're going to write 4 to the second power, and then equals this expression. Equals x squared minus 2x minus 8. Well, we have a quadratic term. So if we have a quadratic term, guys, we have to now make sure we set one side equal to 0. But I'm going to make sure write 16 first. 16 equals x squared minus 2x minus 8. Then move 16 over, make sure this equal to 0. 0 equals x squared minus 2x, negative 8, and a negative 16 is going to be a negative 24. Now, anytime we have a quadratic, we have 3 options to solve. Factoring, completing a square, quadratic formula. So in this case, we are going to try to factor. If you need to take a minute to make your x on the side and factor, please do so. But the factors that I come up with are x minus 6 times x plus 4. Those are my factors. Then after this, guys, we are going to set each factor equal to 0. X minus 6 equals 0. X plus 4 equals to 0. Your two x values are x equal to 6 and x equal to negative 4. Now, before I am rushed to box it up, I have to plug it back in to make sure that it doesn't give me a log of a negative expression, right? So I have to plug it back in here and in here. So when x is 6, 6 plus 2, okay, that is going to be a positive 8, so I can keep that one for right there. 6 minus 4, positive 2, so 6 is going to work. Let's plug in negative 4. When x is negative 4 plus 2 is negative 2. That is not going to work. So guys, we can only keep this one. So 27 says log base 5 of x plus 2 equals 2 times log base 5 of 10. So we do have one log on each side. And that means, hey, some of us said, oh, I can just gonna drop them. That's not true, okay? Remember, we have a 2 right here, and that doesn't have a log. So make sure we isolate the log on one side. So I'm gonna subtract log base 5 of x to both sides, okay? So now this is going to be 2 equals 2 times log base 5 of 10 minus log base 5 of x. So always try to move all your log to one side and the term without the log on the other side. We have two logs on the right, so let's condense it. First, we are going to use the power rule and use that as a log base 5 of 10 square, okay? Now 10 square, that's going to turn into 100. So log base 5 of 100 minus log base 5 of x. Now as you can see here, guys, we now need to use a quotient rule because we have a minus. So 2 equals log base 5 of 100 divided by x, okay? Because we only have one log on the right side after condensing, we now need to rewrite it in exponential with your base being 5. So 5 to the x, okay, I'm sorry, 5 to the second power equals, and then equals this piece. So 100 all over x. 5 squared is going to be 100, so I'm going to move my equation over here. 5 squared is 100. I'm sorry, 5 squared is 25 equals 100 over x. That's what I meant to say. Equals 100 over x. Okay, x is in the denominator, so we have to multiply both sides by x. Okay, so 25x, guys, equals 100. Divide both sides by 25. X is going to turn out 4. Okay, now if we look at our original question, there's only one x location, and if we plug 4 in there, that is positive. Therefore, we can just box that up. Okay, we have 2 more in this set of questions, okay? Now, on 28, it says 2 times log base 6 of 4 minus, that got cut off. I'm hoping it's 1/3. So I'm going to write 1 over here, guys, 1/3. 1/3 times log base 6 of 8 equals log base 6 of x. So guys, we have 3 logs, okay? That means there are 2 on the left and 1 on the right, so that means we have to condense them. To condense them, let's use the power rule first by moving all the coefficient as an exponent. So log base 6 of 4 squared minus log base 6 of 8 to the 1/3 equals log base 6 of x. Okay, now 4 squared is going to be 16, so log base 6 of 16. Guys, to the 1/3 power, that is the same as cube root. Okay, cube root of 8 equals log base 6 of x. Now let's simplify cube root of 8. Cube root of 8, guys, is 2. Okay, so log base 6 of 16 minus log base 6 of 2 equals log base 6 of x. Let's use the quotient rule because we have a minus. So log base 6 of 16 divided by 2 equal log base 6 of x. 16 divided by 2 is 8. So log base 6 of 8 equals log base 6 of x. Whoa, this is so nice. Guys, we have one log on the left and one log on the right. We can drop them, and then x is going to be 8. So that question looks extremely scary, but it really isn't. So when we plug it back into here, it's positive, so we can keep it. Oh, wow, that's super nice. All right, 29. Very similar, except this time we have natural log, okay? Natural log of 4 plus natural log of x plus 1 equals 2. So we are going to use the product rule to condense these two natural logs because we have an addition. So natural log, which is ln of 4 times x plus 1 equals 2. Let's distribute this out really quickly. Natural log of 4x plus 4 equals 2. Remember, you can go straight to the base of e to the second power, but let me just help you guys recall why we're using base e. Natural log is log base e. Okay, so natural log is log base e, but natural log is so important it has its own name. So now because the base is e, we're going to write e squared equals 4x plus 4. Remember, we have to write in exact form first before we can use a calculator. E squared is just a number. Remember, e is 2.718 and we're just squaring that. It's just an ugly decimal number. So we're going to leave it like that, but we are going to try to solve for x. So e squared minus 4. Oops, e squared, not minus 4. Let me erase. E squared minus 4 equals 4x. Now divide both sides by 4. You can keep it like this. It's perfectly okay. So x equals e squared minus 4 all over 4. Okay. Now, if you don't want to keep it like this, right, another way to kind of go about this is e squared divided by 4 minus 4 over 4, which also allows you to go, okay, well, that can be reduced on 4 over 4 is minus 1. So this is another exact. Now, we need to use decimal or your calculator and get the decimal approximation. Okay, so we have e, so type in e and then caret square. As you can see, it's 7.389. Now we want to minus 4, and then we want to have the whole thing divided by 4. So our decimal approximation is 0.847. Now earlier I said you can write it this way, right? I said, okay, e, just type in e, caret square, divided by, oops, and then divided by 4, and then we said minus 1. So they're both the same decimal, okay? So 0.847 is our decimal approximation. Okay, so now I'm gonna do the decimal approximation right here, 0.847.